Welcome back, fellow scrubs. This is Spark D Wiz. We're back with more Retro Mansion game project, or whatever you want to call it. We're gonna be picking up tangentially about this Hunter Point thing, but the platforming code for the square version, I guess, or the box only version, if you want to talk about it that way. And let me switch it on over. So the basic idea is we're going to be kind of building on top of the makeshift platforming code that we did last time. Or not last time, but we did in a previous installment of the stream. That's gotten us this far. But there's some issues with it, and I didn't bother addressing them at the time because it's just quick and dirty to get them up and running and doing stuff. And so we'll be fixing that up, and I'll explain how that kind of works and what's wrong with it and all that. But we won't necessarily be getting to the center point stuff. I'm still doing my research on how best to handle that kind of system, and it's becoming more complicated by the second every time I think about it. So it'll be a little bit before we can do something intelligent with that design. So I figured we'd at least shape this one up, and that at least give us a little bit of solid, direction on how the movement's going to be handled and this and that. Then we can start doing some, arguably more interesting, depending on how you look at it, things like, laying out levels. And, transitioning like between two different rooms, like unloading a scene, unloading another scene, do something like that. That's the kind of direction I want to go in for now as far as the programming side of things. And then we can actually, start testing out level concepts and how things feel and that kind of stuff. So this will be the basis of that. So let's look at our player here, which we have been lovingly calling Ricky. Ricky's the kid. All right, so we've got player controller script, which I think should be pretty much intact from what we had last time that we worked on this. So, let's see. Let's do a quick step through of what we've got so far. Alright, we got inputs, kick, spray, anchor, walk speed, fall speed, jump speed. Okay, when we update our inputs, we check about the kick. We're going to disable the kick for now. It causes problems anyway. So we update movement, and then let's see, face left, face right, velocity. Okay, are we actually moving in here? Yeah, we're actually moving in here. That's fine. That's okay. Check horizontal and check vertical. Okay. Just making sure that I didn't change anything and break it in the meantime. It looked like it was functioning right, but just want to make sure. Okay, I think it all looks pretty cut and dry. Okay, so we're gonna add, sometimes it gets a little wigged out in corners and stuff. We're gonna add some code that handles that. So if I don't think it's using the skid width. Oh, kind of. So it's shooting down the rays like inside. Let's see. If we step it. Oh, I can't do it that way. Do we have inputs here? For... I think we just got... Yeah, we just got keyboard inputs. Let's see if I can add controller inputs real quick. Because you can't... When you pause the game, you can't actually use the keyboard inputs here. Because when you hit the frame advance, it takes keyboard focus away from that and puts it on the UI. And then you can't actually step through anything. So it would be better if... let's see. I think we could get access raw. It would be better if we have the controller, because the controller will let us step through it while doing it. Horizontal, I think is the default name. Oh, what's it give us? A float or something? Yeah, okay. I would assume if we're going... Oh, if we're going left, it should be negative, probably. And if we're going right, it should be greater than... Actually, we should do this. Horizontal axis value. Or just that. Well, instead of sending the string multiple times, we'll cache it to a value. And then we'll just compare this one. Also, it'll help us debug a little bit in case something's goofy with it. Okay, get access raw, horizontal. I think that might be all we need. We'll find out in a second. Where's my controller? Where's my controller? Here it is. Nothing. Not a single damn thing. That's funny. Well, apparently that doesn't work. Oh, wait, hold on. The right stick? Wait, why the hell is the right stick? Alright, you know what? Screw it, whatever, that's fine. So, oh, apparently doesn't work when it's stopped? What the heck? What's up with that? Well, that's weird. How come? Okay, hold on. There could be a setting for that. See, in the other project I'm using, the InControl plugin, which handles a lot more stuff, but here, not so much. We're eventually going to be redoing the input system from the other project, also with this one, so I didn't bother to port over that one because it doesn't make much sense to have it. And we're just going to redo it anyway. Okay, let's see. Might be under other settings. Logging. I know there's something in here about inputs. Active input handling both. This is the input manager. It said it had to restart. Yeah, okay. Fine by me. Go ahead. Okay. Let's go back now. We've got that set. Let's see, unsafe code, disable. Hardware statistics. What I'm looking for is if there's something that's like run in the background or accept inputs in the background. Maybe that's in here. Project settings? Or is that what this is? That's player settings. I hit project settings. Where the hell is it? It didn't pop up. That's great. Oh, it's over here. Never mind. I'm dumb. Damn it. Hop out. Hop out. Hop out. Hop out. Hop out, please. Thank you. How about not being off the screen would be nice too. Okay. Let's see what the input options are. I don't usually deal with the normal. Oh, this is just, yeah. Okay, yeah, so let's see. Horizontal. Axis X. Okay. X. Oh, what's this one now? There's two of them. That's the right stick. I'm pretty sure. Weird. So why doesn't this one work? That was what, 4th and 5th? Hold on. What was that? 4th and 5th axis. So 1, 2, and 3 don't seem to do anything? That's weird. There's something not right about that, but man, whatever. Works, it works. Alright, now that it's only using the original input system, let's see if we can get anything. Can we step through here? Wow, you still can't step through here and hold a direction. Well, that's bogus. What the heck? Okay, now I'm mad. Now I'm real mad. Alright, man, that complicates things. Because we can't move and step through it at the same time. Oh, come on. I don't know why that's not working. Alright, you know what? Where is add tab? Oh, they took it. Did they take it out of here? I think the asset store used to be in there. Window. Asset store. Alright, we got asset flip the stream. You ready? This is how you make Unity asset flips and upload them on Steam for quick money. Yeah, this one. I mean, I'm not logged in, am I? Shit, hold on. I gotta blank the screen out. I gotta log in. Sign in. Hopefully I remember my credentials here. Oh boy, look like it took it. Hey, look at that. Look at that. Okay, alright, let me bring it back. I remembered the first time. I'm so proud of myself. Okay. Okay, yeah, you purchased this. Import, yeah. I'm just gonna do a quick and dirty one. I'm tired of dealing with all this bullshit. Yeah. Alright, all that shit. Import. This is ridiculous. Alright, so you download the assets and you drag them into the thing. And then we upload the Steam. And then we'll get like $100 until people figure out it's shit. And then you just do that every weekend on your phone. That's how you make a Unity game, right? It's something like that. Reload, sure. Just gonna close it. Doesn't matter. In control needs to modify your input settings. Please run that. Okay. In control. Setup input. Manager settings. Cool. Successfully modified. Hey, hooray! Check the settings. Settings are fine. We're getting somewhere. You see that? See how easy that is? You just put the asset in and do the thing. I'll be honest, this is the only one I've ever actually bought because it's just... This guy went through the trouble to do what I was gonna do anyway, and for $35, it saved me like 2 months of work, and I'm like, cool. I'll definitely do that. So this is a real legit thing to get off the asset store. I think it's made by Gallant Games. I don't know. I assume that he just did this for his games, and he's like, you know what? This is probably like better than 90% of all the controller code handling code out there. So I'm gonna just like upload this and sell it, and for $35, that's cheap. It's actually really cheap. Alright, so we'll close that. And that's the only time you'll see me open that tab. So is it in here now? Yeah, it's in here. Oh man, now I gotta remember how to freaking do this. It's been a long time since I implemented something like this. Input manager, yeah, okay, and... No. Did the music go weird for you too? Oh, I think it knocked out. Oh, there it is. Oh, there's the music. Okay. I think the wire is frayed. Oh, no, then the other side went out. No, stop screwing up. I have to get a new wire. It's all messed up. Okay, there we go. That's better. In control manager. Here we go. Suspend in background. We don't want that. Enable X input. Enable native input. Oh wait, I think that does X input by default. Yeah. So this is already covered over here. Prevent the screensaver and sleeping. That works. Yeah, okay. Save. Alright, now I gotta remember how to implement this friggin' thing. Oh yeah, we closed the thing. I don't remember if we have direct access to the inputs, or if we have to do it a different way. Let's see. In control. Clever name. Here. Alright, let's see what we got. Oh boy. Oh, a whole bunch of shit. This is not going to be something to set up, is it? Crap, I think I need to make like an action something or other. Input manager. Oh my god, I can't believe I'm getting into this right now. Shit, how did I... Do I have to look... I'm gonna have to look at Pocket Fighter code, aren't I? Yeah, but no, that one's customized for fighting games, so that's not gonna work, right? Shit. Why doesn't Unity just... I don't know. Let's run it. Oh, it's still working apparently, somehow. That's funny. No, I do not want to open the game bar. Go away. Does it go? No, it still doesn't respond this way. Oh, it's so dumb. Why? No, it still doesn't respond. Come on, kill me. Alright, hold on. I'm just mad. Yeah, introduction. Alright, how does this work again? Getting started. Blah, 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 blah. Yeah. Next. Native input. AI reference. Oh boy. Oh, that's just gonna be a ballistic crap. Where is... This is where I am? I'm in getting... No, I'm not. That wasn't getting started. Okay. Yes. Oh, okay. I might be able to just do this. Cool. Okay, I have a feeling there was an easy control option here. Yeah, so... Let's see. Is there like a left? D-pad left? Yeah, there we go. There we go. Yeah, we don't need parentheses. Hey, here we go. I don't do it this way at all. In Pocket Fighter, I kind of wrap it in a different layer. Yeah, screw that. Okay, let's see if this works. Hey, there we go. Hey, there we go. There we go. He can move while we're stopped in time. Sweet deal. Okay, and that way we can see like all the little lines being cast and directions and shit. So, okay, cool, right? Cool beans. All right, now let's get to the heart of the matter. And we've asset flipped our way to cheap Steam money. Okay, we got that. Oh yeah, I guess we need a jump button too, don't we? So, is jumping either jump key or action 1? Let's see what action 1 does. Is that jump? Yeah, that's the jump button. It's A on the Xbox controller. Alright. Yeah. And so we can jump while in time slow. Or time stop. Cool. Alright. We are good to go. Okay, update inputs, update movement, and this is animation, I think. Yeah. So this is update animation. Yeah, I'm just gonna lock this off. Yeah, in its own little section here. Yeah, we'll leave that outside, that's fine. Update movement. Okay. Old velocity. New velocity is set to 0. This holding jump going up and down. Wait, where's... Oh yeah, pressing left and right. Okay, that's your walk speed. Okay. We're gonna keep it like this for now, but we are gonna change this in a moment. Okay, minimum check length. Bounds by 2. Okay, we're gonna change how this works. We're gonna do something called like the collision skin. So, private vector2 skin width was new vector2 0.1 f 0.1 f should be good enough. So what a skin width basically is, let's grab a Ricky. Where's a Ricky? Here's a good Ricky. So say our... I'll use this color. This is our collision for Ricky. Just a Ricky box. Shit. Well, you did. It's a box. So what the skin width means is instead of starting here and looking out for walls and fours and stuff, it's gonna start back one. It's gonna start inside the character. I guess it'd probably be better to represent it this way. It's gonna start inside the character and look out a little bit. And so your skin width, so to speak, is the distance between where the ray starts from inside to the exact outside of the box. And this helps like redetect fours and shit, so that like you're not inside the four. So when you let's use a different color. When you're on the four, if you don't have like the skin's gonna hit this, the skin width's gonna make it so it hits like this, and then it's gonna adjust your position so that you're above the four, but it always gives it a little bit of distance to come back down to hit the next thing. So like if you're already in the four, then it gets really goofy. Like you could actually be like a little inside the four or something, and it's gonna hit immediately and you don't have a good measure on distance. So when you cast the ray, if it's anywhere like here or here, it's gonna be like, oh dude, I already hit it, like I'm inside it. What's the distance to you in the four? 0, because I'm inside it, and it doesn't give you as much information. So if you start here and you go down, it's like, what's your distance? 1, 2, 3. Alright, cool. So go here and then subtract 2 for the skin width, and then you're gonna be right at the edge of the 4. That's the basic idea what this is supposed to do, and it just smooths things out and makes things a little bit easier to deal with. And it'll get like stuck in the floor or the walls and crap like that. So in our Unity world here, we've set it up so that 0.1, a distance of 0.1 is 1 pixel. So we're gonna have a skin width of 1, so it'll be like 1 pixel from the inside. You can really realistically make this any number that you want. And in some cases, the smaller the better. But we'll start with this and see if there are any problems. And if there are problems, okay, we'll adjust. If not, then, you know, we'll do it. Now, it is important that your smallest object being detected should not be the size. This should be bigger than the smallest object you're detecting. Otherwise, that might cause problems too. And we went over, I think, the smallest. Having a minimum size for entities in your space here. Okay, so oh yeah, we're gonna do some other variables too here. We're gonna check if we're standing on the floor, and whether or not we're touching a wall, and touching left wall, touching right wall. We also have to check. Let's see. We have a what way we're facing. I think. So we got sprite is facing right, but what else do we got? We need to keep a value of the last direction that we were facing, because we need to be checking. You know, even when we're standing still. I don't think we're doing that currently. Yeah. Okay, we'll have to make a value for that. Let's see. We might change the way that this is done, but we'll do this for now. Facing right. Okay, so we want to check here if velocity.x is greater than 0, facing right is true, else if, this is important, it has to be an else if velocity is less than 0, then facing right is false, but we don't change it if velocity is 0, so we're going right and then we stop going right, it won't change it, we're still facing right. And same thing with, you know, facing left when we're going left. Or I should say, right bound? I don't know. We'll come up with a better name for this after. Velocity is right bound. Because you could be being pushed back and still be facing the other direction. So I shouldn't say that it's facing right or left. No, I didn't capitalize the I correctly either. Derp. Okay. So the minimum check length, this is gonna change. I don't think we're gonna use this. Yeah. Let's get rid of that. Actually, hold on. I need to get rid of the whole variable. Where are you? Minimum collision size. What's that used for? Oh, okay, that's our minimum. What I was talking about before, that's our minimum size. I'm gonna call it the minimum physical size. We'll have to reset that in the editor when we come back to it. But for now, it's fine. Alright, we got rid of that. Okay, so we're going to change this with the skin width now. Yeah, and then we remove the skin width from our velocity distance. When we're done there. Okay. And I don't think we need this anymore. Oh, we need another one of these. Velocity is upward bound. And same deal. That's right, yeah. So going up, we're increasing Y. Going down, we're decreasing Y. So we'll, oh, yeah. Upward. Up, up, and away. There we go. Okay. Same thing applies here. We're still going to be looking up or down if our velocity didn't change. Okay. Okay, let's do the left and right first here. Okay, check distances here. Checkpoint origin. V-check origin. V-point distance. What are we doing here? Why did we do this? V-check, V-check. V-count. Oh, okay, this is the vertical. Is this just debug? Yeah, okay, that's debug. I figured. Okay, so this is, we're detecting our minimum physical size. How many vertical counts? Hey! What's up? And this is the distance, yeah, this is the distance between each of those points. Okay. Now here we're adding stuff, we're probably going to take that out. Yeah, we don't want that correction. That's what our skin was going to do for us automatically. Okay, I think we want to change this here. Where all is this being referenced? Yeah, there's a bunch of places. Can we go to this? Oh, it's right here. Okay. Okay. We need to make a new value here. So collision bounds is going to equal our collision frame that bounds, but we gotta shrink. We gotta shrink it down. Expand. Like maybe we could do a negative expand. Vector 3 or float. Yeah, okay. So let's see. We want to do a vector 3 of the skin width times -1, so the negative skin width. And that should shrink down our bounds. And we're going to use this instead of these ones. F3. F3. Okay. Yeah. We're going to use that instead. And so that gives us a different sort of starting point here. So basically what I'm saying is, when we've got this here, we're going to be like, alright, that's cool and all, but we're going to shrink it down to here. We're going to shrink it down by our skin width, because when we check, we're going to check like this. And we need to know that we start here to check in the corners. That's why we're doing what we're doing now. And same thing for like the down in the corners. It just makes it a little better here. It kind of compensates for having that skin width. Let's see. I think that'll work, because as we're expanding, but we're expanding in the negative direction. Oh, I think it needs to have that cast, so we'll just do that. In fact, let me make this public. That way we can actually screw with it in the editor, and you can see how that changes things. Also, where's our gizmo? Do we have gizmos enabled here? We don't have gizmos. Well, I'll be. Let's close that. Let's add a gizmo. Gizmos are like little helper things in Unity. So on draw gizmos, if that actually exists and is a thing. Oh, not equal to null. That works. Okay. So we want to draw. Well, gizmos.color equals color.green and gizmos.draw cube. Yeah. So our center is going to be the collision box center and the collision box size. And so it should draw. Oh wait, we want a wire cube. So it's basically just a wireframe version of the cube. That way we can see what it looks like with the shrunken skin width. It'll just be easier to visualize it that way. Okay. Back to horizontal. So we're still getting rid of these collision frame dot bounds. Okay, so the unknown we have now is this, and that's good. We want that. Yeah, let's comment out that vertical for a minute. In fact, I'm just gonna comment the whole damn thing out there, so we can test the horizontal before we move on. Okay, I want to get rid of this checking whether or not velocity is up or down, or up, down, all around. That was gonna make a dad joke, but I chose against it. Something about the hokey pokey. Do they even teach kids about the hokey pokey anymore? Or was that just a 90 kids thing? Okay, so what we're going to do here, now that we have this, whether velocity is right bound or not, yeah, so if velocity is right bound, then we just do transform right. But if it's not, we do transform right. Actually, just press negative on it. You can just do negative transform right. So which is left? There is no transform dot left, so it's just a negative of transform right. Hokey pokey is eternal. I know. It just seems like one of those things that just fades away into existence, and then kids today be like, "What the fuck's a hokey pokey?" What's that all about? Yeah, let me tell you. I'll tell you what it's all about. Alright. So this way we don't need to check if the velocity is left or right. We just have this check here. So skin width. Yeah, so the skin width is going to be the velocity x plus that. Let's see. V check right. Oh yeah, okay. to v checkpoint. Now playing jacks on the sidewalk might have faded away, but not that old hokey. I don't know if I've ever actually played jacks on the sidewalk. Maybe once or twice. I don't know what the rules of it are at all. I just can't remember it, so I'm thinking I probably haven't played it very much. We'll call that viewpoint count. Just saw V checkpoint ID. Or I should say viewpoint check. I know, I'm just getting ADD with this shit. Crap, where'd it go? Viewpoint check ID. Okay, that makes more sense to me now. The check origin. Is the bottom. Okay, we're gonna have to change this, I think. So this should be the collision bounds dot. Let's see, we're checking from the right side, so is it extents? Extents of the bounding box is always half the size of the bounds. Yeah, okay. So view check origin dot x plus equals that or yeah. You gotta do it this way. Extents.x and negative extents.x. So you see where this is going. If it's right bound, we're going to add and go to the right, and that's going to be our starting point. If not, we're going to go to the left. That's where this velocity is right bound thing really comes into play. Because if this doesn't change, if we were walking to the right and then all of a sudden we stop walking to the right, this is still facing the right. Velocity is still right bound. And so it will have the data to determine what we need to do here. And that allows us to get rid of that clone of the checking its velocity left or right. It doesn't matter now. It's going to do exactly what it needs to do, regardless of what direction was last. So it cuts down on code and just makes the whole damn thing more simple. And then the distance is just because we give it a direction, so the distance is always a positive value. We don't have to change that. So then we analyze the results. So we'll check. Let's see. Yeah, okay, so if we run into something, we need to modify velocity.x as okay, we need to do this check here too. I guess we'll do it this way. It's gonna be times 1 if it's right bound, and it's gonna be times -1 if it's left bound, because the velocity is gonna be different on left or right. You take the distance of what it hit minus the skin width from the outside. So if you're moving this far, oh, we get a different color. If you're moving this far, you're really moving this far here, and then if something hits it'll take out the 2, because when you move, it's going to move you from here to here. So you have to subtract that width. So it might be easier to see with this here. So when you start the ray, it starts here, and it will go all the way to the end. And you've got that, or I'm sorry, look at this one here. You get the skin width, and then here's your velocity. Velocity is purple, and together it's like 1, 2, 3, 4, 5, 6, 7, 8. It's 8. But if you hit something here, it's got to be like, all right, we gotta. We sent the ray 8 pixels to the right. I'm saying pixels. I would say units. 8 units to the right. But your velocity is really only 6, so we got to subtract those 2 units that we took to get to the outside. That's your skin width, and so you're really only going to move up to here, because if you did a velocity, if you didn't subtract for the skin width, he would end up like over here. No, that's inaccurate. You would end up here, at this here, beyond the wall. So you're just basically compensating for that skin width here, and that's all that this code does. So you take the distance minus the skin width, which are both always positive values, and your velocity, you know, obviously you gotta negate that if your velocity was negative beforehand. So, with that out of the way, then your check distance is now equal to the distance that you last hit something on. And the reason we do that, which I may have explained before, say we're checking at a distance of 1, 2, 3, 4, 5, 6, 7, 8. 8. And you end up bumping into a wall. No, hold on. Yeah, okay. So you end up bumping into a wall like this. But down here, there's a closer wall. No, actually, I gotta do that backwards. You end up bouncing into a close wall here. But there's another wall down here that's like, you'd still hit it if it was 8. 1, 2, 3, 4, 5, 6, 7, 8. You'd still hit this wall. But you want to stop at this wall on top. You want to stop at whatever's closest to you. No, actually keep that. So even though you hit that wall here, I'm going to use a different color here. You really only went this far. So now your new check distance is going to be 3. And it's going to check 1, 2, 3. I didn't see anything. 1, 2, 3. Didn't see anything. 1, 2, 3. Oh, that's 4. Yeah, 1, 2, 3. Didn't see anything. 1, 2, 3. Didn't see anything. If you didn't have that, if you didn't do that, then you would be checking the whole 8 again. And it would be like, okay, alright, nothing. Like, oh shit, we hit something. Alright, we're over here now. So now we're gonna move Ricky here, except now his face is inside the wall. Because you're checking only one direction, going up and down. So when you cut it short, it won't detect something farther away. So you're only going to move him to the closest object near the wall. Because otherwise this code will run, and it will just change your velocity to higher than it should have been. But if you change the check distance, well, now you're all good. Yeah, so the distance between that and the object. Because this takes into account the skin width is already added into this distance. Because we did our check distance up here with it in there. So this is going to automatically calculate all that inside of it. So all you have to do is set check distance to the new distance and you're all good to go. And then it will end up doing that. So that looks good. That might actually be okay. Let's give new Ricky a try here. Good old Ricky. I'm gonna move him down into the pit because then we'll actually have something to bounce into here. Now he shouldn't be falling anymore. Don't think he... Actually, hold on, let me see. Let's close that. Okay, he won't collide into anything. But he will still be falling, so I'm going to take out the jumping code just for the moment. Because here he'll still actually move and fall, he just won't be colliding with anything. And that will screw our test up. So theoretically this should just move Ricky forward, left and right, rather. And let's see. Syncing the controller up. Oh, he ain't moving. He's not moving anywhere. Ricky, what are you doing? Oh, there we go. Maybe the controller's just not working. For whatever reason. That's great. We just had the controller working and now it don't want to work. Oh no, it's the D-pad. That's right. Okay, I'm sorry. I was hitting the wrong thing. Okay. So let's look at Ricky down here on the little viewport. Okay, so we move him. This is absolutely not right. It's not right. I think. Or is it just a frame behind? It might just be a frame behind. Oh, now it's okay. Okay, the right facing does not seem right. Left facing seems like it might be right. Oh no, it doesn't. Yeah, I think this is old because this is the old info. Yeah, this is before he moved. That's why you see it like this. And now you're seeing the collision box after it moved. That's why they're overlapped funny. How do I want to fix this? Because we do want to see what it looked like before. I think the best way we can do this is... And let's just copy this. Collisions bounds before reduction. And then we can draw this one down here. Yeah, so we'll just there. Okay, that'll show us the outside and the inside, and the skin width has to correspond to that. Alright. Their skin width is 0.01. We did change one thing though, right? That I need to refine here. No. That's right. Alright, oh, that was. That might have been something else. Oh, the horizontal counts. We'll just say it's 2, which I don't think we need just yet. Okay, alright, so Ricky's moving along, and these rays are not right, so we will have to correct that. But now see here, the skin width is here. See how it got reduced and pushed in by roughly 1 pixel. And then the skin width is about right here. His velocity, his skin width is from here to here, and his velocity was like a sub-pixel. Now here it's in the wrong spot. It's got to be up 1, but I think I know why that is. The top one, was the top one in the right spot? No, it's also in the wrong spot, but I think I know why. Yeah, I think what we'll do here is just make this a new vector 2. Collision box dot center. Oh yeah, yeah. Do this. Collision box dot center plus oh. You know what? Actually, I'll do 2 of these. Vector 2. Origin correction. So, if we're right bound, then origin correction will equal new vector 2 negative x. And let's see. What do we want to do here? Do we need to change the y? I don't think so, because we're using the center here. Okay, so plus origin correction. Don't like that for whatever reason. Is it because this is a vector 3? Yeah, okay. Capitalize. Okay, and then else origin correction is going to be positive. So let's see if this sounds right. We're right bound. Actually, it's reverse, I think. Oh no, we do need the other. We do need the other. Let's see. We're going from bottom to top, so this is the center, and we need the negative. We need negative. I think that's right. We need to go down. We need negative extents, which is basically just the radius of the bounding box. Yeah, always have to size the bounds. So we gotta go down halfway, and that'll put us in the bottom center, or well, bottom right, and then the bottom left for this one. I think that's right. And then we apply that offset to the center. I think that makes sense. Alright, we'll know in a second when we see the result. Alright, Ricky. Pause. Hey, that looks better. So we're in the inside after the indent from the skin width. That looks better. And that looks better too. Okay, so that was right. Now we're only checking again from the corner here, as opposed to over here. And you see that exactly here. Oh yeah, these are just debugs. Alright. So maximum physical size, minimum physical size is 1. Yeah. so how far are we here? So this is 39, 38. Okay, so this block here is 1. So Ricky is really about 3 units tall, or 2.5 units tall. He should have more checks here. I don't think it's rounding up is the problem. So let's see. How do we fix that intelligently? And let's do this. Float. Point division. So we turn it into an integer here to reduce off the fraction behind it. And then we compare if the integer is less than the division, meaning if there is a remainder, then v-point count plus plus. And then in the end, it can't go under 2 anyway. I think that might help it. There might be an easier mathematical way to do that. That's just the first way it came to mind. Seems like there might be like a trick you can employ there. Oh. And there we go. Now we've got 3 like we should. 1, 2, 3. And again, we're going from skin width here plus the little micro velocity that he's got. Because you'll notice he only moves in very small increments. And that's what this is here. Which is about a pixel-ish. Anyway. And then when he's standing still, he's still got, that's funny, why does this start here? We might have a left-right mismatch going on. Let's step them the other way for 1 frame. This shouldn't be that long. Don't know why it's that long. What's our velocity? Should be 0. Yeah, our velocity is 0. Skin width is 1. Alright, where is this debug line being drawn? We might be drawing it incorrectly here. Yeah, I think we're drawing this one incorrectly. Let's try this. Will that work? So this will be checkpoint origin, and then the point it's going to is the checkpoint origin plus the now distance times the transform.right. And it'll be negative if we're facing left. I think that should be okay. I don't think we applied the directionality to the debug readout. Okay, it looks... So at least go in the right direction now. You see when he's facing right, it goes that way. And when he's facing left, it goes that way. Oh, I know why it's sticking out there. We have to multiply the skin width by 2 when we reduce it. Because we're doing 0.1 in every direction. So we're doing 0.05 currently. It should be 0.1 in every direction. And it was actually incorrect. It was taking the 0.1 and dividing it by 2, because say you're taking 10 and you're subtracting 1 from it. Now you've basically split that 1 into 0.5 in each side. But we need that 0.1 to literally be... Yeah, here we go. Okay, now everything's lined up correctly. This makes sense now. The skin width is bigger, as you see. So yeah, it's actually a whole pixel now. That's exactly what we were expecting to see. It's a 0.1, it's a whole pixel. Yeah, so we had to double that because it's 0.1 on the left and 0.1 on the right. But if you just subtract 0.1 from the width, you're not going to get that. You need to subtract 0.2 because there's 2 sides to it, and the same thing with the up and the down. Oh boy, Ricky's actually going, and he's freaking out at the corner here, but that's okay, we'll fix that. Ricky, what are you doing? Ricky, what's wrong? Ricky, what's wrong? What's going on? Why are you all flipping out? What the hell? What is going on? Why is Ricky in the wall? Our correction code is probably wrong. Something's not right. What happens if he goes to the right then? Does he... Okay, he stops okay on the right, so our correction code is just wrong. Hey Ricky, what's the matter? Are you okay, boy? You don't look okay. Okay, and then see here, it detected that first on the bottom, and then here it's only checking up to that point that it found the wall, and it's only checking up to the point it found the wall. So you can see that code in action, and then there, snap to it, and he can't walk through it. There's actually a little gap there. I'm not sure why that is. It shouldn't be that way. I don't think. Plus just a floating point error for when scrolling the box. It should be closer than that though. You know, I would expect him to be closer than that. Oh, you know why? I bet it's because the actual physical ground is not lining up with the pixels here. Let's fix that real quick. Ground tile. Solids. Yeah, here's the collider wall. Okay, it was just a visual mismatch. See, he's flush with the collision wall here. So if I walk away, you see the green line here, and he comes back, and boom, and he's stuck to it. Okay, that's all that was. So that we know that the ground is actually slightly wrong then. So. Bloop. There we go. Yeah, how come these aren't showing up as actual meshes here? I should be able to just disable that and then see these. Oh, because the mesh renders are disabled. That would explain that. There we go. It's a little intense, but let's see. Let's go to the material here. Let's cut that down a little. There we go. That's a little better. Yeah. So Ricky comes back. He touches the wall. And he goes in and he stays. And then he gets pushed out because of the skin width here. He will never get inside this part here. Cool. Okay, so our correction code just isn't working in the opposite direction then. Let me turn off the ground here and turn these mesh renderers back on so we can see the floor at all times. Alright, let's just take a look at the code for correction here. So velocity is right, it should be positive. If velocity is left, then it should be negative, and that's what we're seeing here. So, distance minus the skin width, that's fine. It should be okay then. Why isn't that working? Well, let's attach it. Move it to the side here. You can't see it, but I'll bring it back when it triggers. Bunk. And there we go. So the velocity is positive 0.16 blah 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 blah. The distance apparently is 0. Minus the skin width. So was he inside the wall? No, we can't check because it's locked up. Hey, distance is 0. That's weird. Sticky Ricky. Yeah. Sticking to them walls. Right, so skin width X is 0.1. Alright, this is not right. This can't be right. True, so you get times 1. Wait, why is distance 0? Something ain't right here. Something ain't right here. Something's weird. Wait, what's this? What's this checkpoint origin? 0. Checkpoint origin. Oh, it's equal to that. Okay. And then we add distance from the bottom to the Y. Okay, that's fine. Huh. The only reason I'm thinking it might be 0, it should always be a minimum, unless they're like inside the wall, it should always be a minimum of that like 0.1. Something's not right. Because then velocity is going to get set to a negative. And that's not right. It's not right. Right? Or is it? Yeah, distance should never be 0. Because when, yeah, the distance is 0 would mean that it collided with something here, not here. Yeah, that's weird. I don't know why that's doing that. The only reason I can think is 0 is if it starts here and shoots to the left, but that doesn't make any sense. Alright, we're gonna make a new debug thing here. View check origin, debug. We're gonna store this and see what the heck it is. And not only that, we're gonna gizmo it. Draw a sphere. I'll draw a wire sphere, that's fine. The center will be this here, and the origin will be 0.005f. Sorry, 0.05f. And we'll color it red. So now we'll know where the things start from. And you know what? We can actually go one step further. No, we don't want to. Because there's multiple arrays, I was going to say we could go a step further and see where it's actually heading, but we don't really need to do that. No, okay, the origin's right. It's right here. And it's shooting to the right. Why is the distance 0 then? Okay, let's do it up again. The distance from here to here is obviously not 0. Oh, it's detecting something, even when I'm sitting still. Yeah, that's what I mean. That's fine. Let's hold right and advance it 1 frame. There we go. Yeah, our velocity is now 1. And the result is distance 0.01, that's fine. Skin width is 0.01. I'll show it here. So this is going to turn from 1 to 0 effectively. It should, because the skin width, it's only getting to where the skin width is. And the distance is like 0.010004 or whatever. That's fine. Minus the skin width, which is 0.01. That'll result in effectively 0. So 0 times velocity is right bound times 1 should be 0. Right now it's 1. So if we advance, it's really small. It's like that point. Yeah, it's e minus point or minus 7. So that's a really small number. Don't be fooled by the 3.7. There's 7 decimal places to the left from here. It's a really small ass number. That's fine. And so the neg check distance gets from 1.1. Yeah, okay, and they're feeding these to us in order of closest distance too, so we checked our closest distance and we're out of here. So tech distance is going to be... Yeah, actually we're not even checking again, so I'm not even sure why the check distance is getting changed here. Yeah, that's fine, whatever. And then we break to get out because we're done. But yeah, that's working okay. It wasn't before though. I don't know, something was goofy. Okay. Well, given that, let's take a look at here. Our origin is correct, because we're zeroed in on the corner here. But Ricky's he's freaking out. So, let's see what's going on here. Okay, so Ricky walked left. His velocity is negative 0.1 blah blah blah. So he's got to move 0.06 at the end of this. His distance is 0? Okay, this is where it was messing up. Distance is 0. How is distance 0? Yeah, actually, take a look. It isn't even right here. Hold on. Something ain't right. Something's not right at all. Let's step Ricky through. Okay, now here's the problem. It's starting at this point and it's going right. I had a feeling there was something like that going on. So the raycast here. Right bound, it's right. There is no dot left though, right? Yeah. So if it's not right bound, it's left bound. We're going to the left. These sometimes get a little goofy. Sometimes you have to use round parentheses. I don't know if that's what's going to help this here, but yeah, that's distance or correction, right? Yeah, the origin, which is fine. We see the origin's fine. Wow, let's compile it so it stopped. Okay. Still not right. Yeah, it's not right. Unless, hold on. Unless the debug's just not right. I don't know. Oh. Okay, that might have been why that was wrong. The debug may actually be wrong. Or debug view. Ricky, where are you, boy? Yeah, that's right. That's right. Alright, our debug view looks like it's been right. No, it's still going the wrong way. Maybe the ray is actually just going the wrong way. It would explain the distance of 0 because if it hits here, where it's starting, then that might explain that. Because, Yeah, let's walk into the wall. Yeah, because he's going into the wall. And he's like, oh, I'm at a distance of 0. Yeah, because you're like right here. And then it somehow gets out over the course of 2 steps. Okay, so when he has a neutral velocity, it seems... Whoa, what the hell's up with that? Is he really moving that fast? He's not. Alright, that's pretty chill. That's not right. Oh my god. Alright, our debug thing's not right here. It ain't right. It ain't right! Check this. Oh man, what the hell? I'm gonna change the code here. Vector 2 new vector 2. I'm just gonna do it this way. It's kind of a cheap way to do it, but it's not giving me much choice here. One more parenthesis. No. Oh. There. One less parenthesis, rather. No? Oh, because it's vector 2 and vector 3. And they don't play nice. Okay. We're right bound. We're going to the right. No, we're going to the left. And then we're not doing anything on the Y. That should fix this display. Good stinky Ricky. Okay. That doesn't look right. What the fuck? Because if this was correct... Oh, he is actually moving that far. Okay. Yeah, I'll say he's gonna move up to that point. Okay, that's correct on the right then. Doesn't look like it, but it is. Okay, so something's wrong with our code here. When he's moving, oh, you know what it is? This needs to be an absolute value. He's moving negative check distance. That's why. So this has to be absolute value of velocity because we're checking distance. Because if this is a negative number, it's not gonna work out. I bet that's what it was. All right, we're getting it, slow but sure. We're getting there. All right. Yeah, there we go. Okay, I think he's good now. Yeah, we step it and boop, and there we go. Yeah. Thunk. Yeah, and then you see the result. The thinner green line he's already gotten there. Boom. Cool. Okay, we're getting somewhere. Ricky's doing it. He's doing it, everybody. He's running in the fucking walls. Ricky, stop. Stop running in the walls. Alright, cool. Let's save before it blows up. I'll be pissed if we have to do this over again. Okay. Sticky Ricky. Okay, so then we're gonna kind of copy this code and use it for the vertical. I'll be honest, I don't think there's anything here we need to save. I'm gonna just Yeah, I'm just gonna wipe it out, and we're just gonna copy it, like kind of like what we did last time. I'm just gonna copy it and adapt it. Actually, the only thing I will save is these parts. Yeah. And then we'll get rid of the rest of this. So H count. Horizontal, horizontal, horizontal. Horizontal. So, and this is going to be minimum size X. This will be bounds X. Oh yeah, that's the debug. Okay. One count. So move H distance size.x. Okay, here, velocity is upward bound. Velocity is upward bound. We want to start let's see, where do we want to start? We just have to pick a side. We can start on the right side and go to the left, or the left side. Let's start left side and go to the right. So if we're upward bound, then we're positive y. If we're downward bound, then we're negative y. I don't think we have that. We should though. We should have an H. So we'll duplicate that. And we're gonna draw that H. And we'll make these actually smaller. Go to 0.02. Let's close the horizontal. Checkpoint origin. This is going to be the X is going to be manipulated from left to right. Yeah, so it's a good thing we started on the left. We're going to add the H distance. So this has to change to H. Because we're going to be going from the left and increasing from the origin. It's going to start on the left. And it's going to increase from left to right. So that makes sense. We want to do that. Then the skin width velocity of y and skin width of y. Just gotta make sure that those are all correct here. Y. And these need to be upward bound. That would just go line by line. We don't miss anything. Okay, skin width y, velocity y, break cast, up, And negative up for down. For downward. And the distance is just this. And we swap the X and the Y here. Because that's what we got to deal with. And, okay, results. If it's us, we ignore it. Okay, velocity Y, it's distance minus skin with Y. Upward or downward. If we're going up, it's positive. Positive 1. Downward is negative 1. And then the new check distance is that if we need it, which I don't think we're actually even using that right now. Okay, that might be okay. Might be alright then. So let's let's reactivate Ricky's thing here. It's gonna start falling again. Don't fall through the floor, Ricky. I'm warning you. You're gonna get the belt if you fall through the fucking floor. You're gonna get the belt, Ricky. Okay. He's falling. What's gonna happen? Is Ricky gonna get the belt? Find out next time. Thunk. Nope. Ricky didn't get the belt. He did not get the belt. Ricky's doing okay. Ricky don't want the belt. Okay, hey. Hey, look at that. Oh, well, Ricky kind of like shuffled a little when he landed there. I don't know what that's about. Oh. I think I know what that's about. Yeah, okay, we actually have to make the move. Once we do one or the other, we actually have to make that move. And then recalculate our bounds at that point. Yeah, okay, so when we do, let's do vertical first, I think. Yeah, so we actually have to apply the vertical momentum here. Or not. You know what? Hold on. So we want to get rid of this. And when we go into horizontal, at the end we actually want to apply this. So the dot X, we're going to actually apply the velocity of X here. I think this is what we need to do. And then we need to recalculate this crap. But we also got to do it here. And in this case it's going to be the Y. Because when we make a correction and say So say like Ricky's in the wall. Like he got moved this way. So he moved into the wall and then he got corrected back out. Oh wait, no. Does that make sense? Maybe that doesn't make sense. I'm thinking like if he gets put into the wall or like the floor, that it was like, oh okay. Like he's up here and he gets snapped to the floor. But that's as far as he's gonna move. And we're still using the bounds of the X that were higher than this and not representative of you standing on the floor. Because this box is was still up here. And then maybe that's incorrect information now. That might be what it is. Hold on. Let's see if that fixed it. I think that's what's going on. Might be what's going on. Alright, let's see if Ricky screws up anymore. If Ricky screws up anymore, he's gonna get the belt. I think that's helping. Maybe? Let's look at it here. No. He's still getting like stuck in the floor sometimes. I don't know why. Like it looked like he went in and he got popped back out. Yeah, at least he's handling corners like a champ. But yeah, let's see if above him works. Okay, so that works. Seems like he's going below for some reason. He's getting snagged in there. But it only happens sometimes. He's getting snagged in the floor for a frame. Yeah, like right there, you saw that jump. What the hell's going on? Oh, you know what? I'm not recalculating the bounds between the two steps. That might be why. No, he's still getting stuck. I saw that little skip when he hit the ground. Okay, that might not have anything to do with it then. So let's undo all that shit we just did. That should still be okay. I don't think that's a problem. It's okay there. Thinking like if I jump and then hold. It looks alright. I don't know. It doesn't look like it's malfunctioning. I want to add one more debug thing here, just for my own sanity. It has nothing to do with this issue per se, but it will be public bounds. It'll be the move result bounds. So we don't have to wait to see what the results were. And we'll do those in yellow. And this will take place after the transformation has been done. So here. That way, when he's moving, we can see that's actually not right at all. It's not right at all. It shouldn't be this. What are we doing? Now that it got moved here, these bounds should be different. These should reflect a different thing here. It should be over to the right, but it's not. Now, why is that? It's dark out. Do you know where your children are? Yeah, Ricky's over here getting the belt. That's where Ricky is. Spoil the rod, or spare the rod, spoil the child. Yeah, I don't know why this isn't reflecting here. Because once you do that, transform that position set. Because you're adding velocity to it, it should cause the bounds here to represent that change in position, but it's not. It's not seemingly doing that. Don't know. It should show them like this faint green one where it is now. That's what it should be showing, but it's not. I don't know why it's not reflecting the value change at that point. Because it is here. See, and then it shows the next frame is actually snapped to it. Well, what I could do I could just add the velocity to it, to the center. That should work. It kind of cheapened it out, but it, you know, it's fair enough. Okay. Yeah, there you go. So that's the result of what happened. So, whatever. We cheaped it, but that's fine. Yeah, so you see, he actually moved from here to here because he was not put upon by anything else. Yeah, so you see there's his velocity being represented and the actual result. Okay, that's fine, that works. As for him getting stuck in the 4, I'm not really sure. I haven't seen it in the slowed down version yet, so it's only slight, but you can, unless it's like frame skipping for some reason. But it only happens when he lands, like you can see it. Of course now it's not doing it. That figures. I don't know. I'll have to mess with it. We're almost out of time now. What I want to do quick, if I can get it to work here. Did we collide with the 4, yes or no? And so we're gonna update this here. Faults. Touching wall. Faults. Touching left wall. Faults. Touching right wall. Faults. So we're resetting all these values and we'll fill them in as we can here. So vertical collision. So if we're going down, and we actually touch something here, then this is true. Because we collided with the 4. And so we can use this information to do our animation stuff here. So if we're colliding with the 4, then we can check I think we have to do this all the way around here. Yeah. Actually, just do this. So if we're colliding with the 4, we're going to run this routine. If we're not colliding with the 4, then we're jumping. That might actually be everything we need for that. Yeah, there. That's all we need for the animation. I mean, we can do other stuff about touching the wall and shit. But that's the basic. That's the signal for time's up. Yeah, we got like 1 minute. Let's plow through it. Let's do it. Okay. So touching left wall. If we need horizontal. Okay. So if velocity is right bound, then we want touching right wall to be true, else touching left wall is true. And then at the end, if, let's see, if we're touching the wall, then it's either touching left wall or touching right wall will be that. And so we can use this now touching wall value to say stop running at wall, and it is touching the wall, then we're not walking. And then if we're not walking, we're not going to play the walking animation when we touch the side. And so we'll turn on stop running at wall, and whoop, there you go. That's how it works. Look at that, just in time. Alright, I'm getting the hell out of here then. We are done for tonight. So thank everybody for hanging out with me. And we got special ultra super patrons that we have to read the names out because they're super generous and super nice. So we've got Zombie Killer, Jerry Berry, Javier Garcia, AJ, and Bryce Nagolinum, who are our generals in the Scrub Army. So thank you very much. We'll be back next Thursday at 7 p.m. Eastern Standard Time, so that's the 25th. July 25th. Man, July's almost over. This is awful. If you want to catch the fighting game Pocket Fighter EX being developed, then that's on Monday. It'll be on the 22nd, 7 p.m. Eastern Standard Time. And that's pretty much it. We got a Discord. We've got a YouTube. You can find links for that crap below. And come yell at us in real time throughout the week, I guess. And that's pretty much it. So I'll see you guys later. Scrub out. Have a good one. And see you next time.